Well, it's been a while since I actually last recorded. It's probably been about a month. Probably going to go back on the YouTube grind for anybody who doesn't know or hasn't seen my Discord. Yeah, I've pretty much been doing a bit of League, and I've been doing actually a lot of League, but I think now I'm going to be stepping back into the YouTube space for a bit. So in this video, we are going to be reviewing Thomas Delaur saying honey is not the same. Oh, by the way, I don't know if you can see this. I got a spider bite right there. So I will say, anybody who does sleep on the floor, that might be a little bit of a problem. It's kind of annoying to deal with the insects. I don't have a way around this yet, but I'll be figuring it out eventually. Anyways, let's go see what he has to say on this and whether or not it's legitimate, because I don't really think that's really that legitimate, but hey, who knows? Let's see what he has to say.
There are increasing bodies of evidence suggesting that honey and sugar are not the same, even though from a simple sucrose, glucose and fructose standpoint, they're quite similar. See, it's not just the sheer macronutrient profile of something that can impact how our body responds to it. And we're talking specifically when it comes down to fat loss in this particular case. Now, the first study that I'm going to mention is...
Okay. I'm going to say right now, there are some differences. Yes. I would say one of the main differences is, if you don't already know, the whole purpose of honey and what honey actually is. It's literally just to feed the bees. It's literally just bee food in some sense. They basically put it in these little like hexagonal sort of shapes, right? And then I don't know what the term is. I don't know if it's like larva or whatever. End up eating that. Yeah, that's basically all honey really is. So in terms of the nutritional benefits, obviously, there's going to be more than just glucose, fructose, and sucrose when it comes to honey. There's going to be like vitamins and minerals and stuff. But anyway, let's hear what he has to say on this, because that's what I see. But otherwise, I don't see really that big of a difference otherwise. They're quite similar overall. They're very, very similar actually overall. But with certain vitamins and minerals, maybe you can mitigate some of the damage a bit, but I still don't think it's ideal.
Is a rodent model study to illustrate a point. But then there's stronger human data that demonstrates some really interesting properties with honey as well, in the same vein when we're talking about body composition. So let's go ahead and break them down. Even though honey is sugar, and sugar can impede lipolysis or fat burning, it seems as though net, it still could be a positive for fat loss. Now, make no mistake, I'm not saying that having honey come in over no sugar at all is going to be better. There's not a ton of nutritional value to honey, but it is certainly a better choice when it comes down to carbohydrates or sugar than traditional sugar.
Yeah. Okay, I'll agree with that statement. He's right on that, yeah. So there is definitely, honey is obviously better, I think, than sugar, just because it has other things besides glucose, fructose, and sucrose. So yes, it's better than the alternative, but even the alternative's pretty bad. So honestly, I don't really see why you would want honey. Once again, my opinion, just stick with meat. And if you really are somebody who you think can control the milk cravings or the dairy cravings, the carb cravings that come after the dairy, usually, because that's my experience, then I would say like go right ahead. But I definitely, I don't think most people can control it. Once they start adding in honey, I think when you start adding in honey, then things start to get really bad. That's what I think. Then you really mess up, one, you sort of mess up your microbiome. Two, you also add tons, and I mean ridiculously large amounts of glycation to the body. Like it's an absurd level of glycation. So not ideal in that sense either. Honey isn't just glycation potential in terms of fructose. It's not just fructose. It's also glucose, right? So it messes with the Randall cycle too. Not ideal. Once again, I really wouldn't do honey. Like if you really want like close to optimal health, but you still have like a little bit of carb, have dairy. Like please God, have dairy. Get kefir, get raw cheese, raw I don't know, whatever. Okay, but don't do honey. Just don't do honey, because honey's damage, it's really, really high. And no, by the way, humans did not have honey before pre-agriculture revolution that much. There's a lot of people who are talking about this in one of my previous videos. I can't remember, but no, this is not common. Like, okay, let's look at it like this. You're hunting for your food in winter. Now tell me when you're going to find the bees. You're not going to find the bees, okay? The bees are not going to be there. If you're around in the Arctic, in the Ice Age, there aren't going to be just plenty of bees to knock down the tree and then you can go get the honey. Like, no, that's not how it works. So that's one thing. Second thing, if you also want to look at fruits, by the way, fruits never looked like they do today. Like grapes, for instance, if you know a grape today, it probably, I'll try to demonstrate this on camera, looked something like this big, right, as a grape today. And grapes before, they didn't even have a fraction of that size. In fact, they were so small, I don't even know if you can see that I'm trying to make a hole, but that's how small each individual grape originally was. It was so unbelievably small. Same thing with avocados. If you look at an avocado, literally, it's just a giant seed and then a small layer of the food, the edible part, basically. So it looked something like, this is the giant seed, and then it has maybe, I'd probably say like this much of the edible stuff around it. So it's like, humans could not sustain themselves off of that at all pre-agriculture revolution. They weren't eating fruits and vegetables because they didn't exist. They existed, but they weren't really edible. And if you really want to go eat one, by the way, order teosinte online. That's just one example. It's not edible, by the way. Don't do that. I really don't recommend it. I heard it's really crunchy and inedible, so don't do it.
And there's some literature to reinforce that. So this first study that I'm going to look at was published in Nutrition Research. It is a rodent model study, but it's interesting because they took two groups of rats. They gave them equal amounts of energy, equal amounts of calories, equal amounts.
Okay, I don't like this calorie stuff because hopefully from my channel, if you watched the whole Real Nutrition Science playlist, which covers everything that, by the way, that I'm saying with references and like a whole lot more. This is BS. Calories don't mean jack. I'm not going to swear. I'm going to try to avoid the swearing part. But yeah, they don't mean anything. So let's see what he has to say.
Amounts of protein, equal amounts of fat, and even equal amounts of carbohydrates. But they gave them slightly different carbohydrate provisions. 20% of the carbohydrates in one group were sucrose, which is table sugar, glucose and fructose. The other group, 20% was honey. Okay, so they used clover honey.
Well, obviously you're going to get a difference. I mean, okay, so let's just look at it like this. We already know what sucrose is. It's basically just huge glycation potential. And we already know what honey is. It's like 30% glycation potential of times 7, which is fructose, I think. And then the other, I can't remember the exact ratios, but basically it was, I think, 30% glucose, 30% fructose, and then I'm not sure if there was another 30% or not. But regardless, even if it was 50-50, let's just say it's 50-50, right? Obviously, if it's 50-50, then 50% glucose, 50% fructose, you're going to get way less glycation potential if you're measuring it in terms of how much damage it's going to be dealing in the process and adipose tissue in this case, because that's exactly what fructose will do. It will go straight to the liver because it can't be converted. It's not regularly converted by the body. Like it's either amino acids or it's fat or it's glucose. And if it's not one of those three things, which fructose isn't, by the way, then the body has a really difficult time processing it, and it starts panicking and stuff. And it's like, oh crap, what am I going to do? So then it goes straight to the liver, which is exactly what the liver does. It detoxifies. In this case, technically, the fructose is considered toxic. Like, by the body, it would be viewed as toxic. So, not ideal. It gets processed directly by the liver. Not ideal. Once again, if you're interested in all the details behind this, it's in the Real Nutrition Science playlist. And I mean, every single video there had so much sources, so much information. I'm not going to be explaining it in this video because everybody asks in the comments, they're like, oh, give me a source, right? Or like, oh, this guy's complete BS, right? Well, just look at the Real Nutrition Science. Look at the Real Nutrition Science playlist, and it covers all of that, like way too much detail. So much detail, in fact, it even exhausted me when I was making it, by the way, because finding sources was not easy. I can tell you. I mean, for the it was sort of easy for me because I already knew 70% of the sources existed already, but I had to find the other 30% on my own. By the way, that was not easy. Anyways.
Now, for 33 days, they had them follow this diet in a very controlled situation, which is the benefit of doing these in rodents. Of course, their metabolomics and or metabolism and the metabolomics subsequently are a little bit different, but either way, it's controlled. The group that had the honey had 14.7% less weight gain. That's huge.
Well, that would probably make sense, right? You're feeding one of them pure fructose. Or I guess the thing that gets converted automatically by the liver, right? Processed straight by the liver, not ideal. Or you can have the other one, which is half fructose and then half glucose, right? So, like, I mean, come on. It's not really, like, come on, man. It's not that huge in my opinion. But, okay, here, there is one thing though I will say. For anybody who's like interested in this argument of, oh my god, I want to eat honey and stuff. Okay, there's only one thing or one possible thing I can see where honey is beneficial or any sort of carbohydrate is beneficial. And that is when you are overexhausting your body and you're over-exercising, which if you're interested in my why exercise is unhealthy video, go check that video out. It's found under the min-maxing health playlist, found under my homepage. But if you are exercising a lot, and I mean a lot, like overdoing it for your body, then I actually think, in this case, adding in carbohydrates is better because you are going to be depleting electrolytes like mad. Now, you can, by the way, if you want to make it actually healthier while you're overstressing your body, I would just get like electrolyte packets. In fact, I would probably be sponsored by them if I could. In this case, Elements or whatever, right? You hear that Element commercial all the time. It's like, oh yeah, buy my Element pack. It's like flavored and has all the electrolytes you need. Yeah, that's the sort of thing that you might need if you're overstressing your body. Otherwise, you probably wouldn't need that. Or if your circadian rhythm or like all these other things are messed up. By the way, if you're interested in min-maxing your health, go check out that playlist. I explain all the details there and what you can do. There's some things that will shock you, by the way.
And there's some reasons why we'll explain. But they also had 20.1% less visceral adipose tissue.
Okay. Well, let's explain why. So I'm going to tell you right now, fructose, once again, processed straight by the liver. Now, what does that mean? That means that when you are trying to make use out of this fructose, or your body is, it goes like, oh, I can't really do anything with this. So here's how your body, so let's say you want to give yourself collagen, right? So you eat a ton of collagen. No, that's not how it works. Why? Because that's not how your body actually makes collagen. You can't just eat collagen and then expect your body to make collagen out of the collagen that you just ate. And the reason is because your body has to break. So there's this barrier, right? Let's just assume, okay, it's like this, right? This is the barrier, and your body needs to pass one thing to the other. But in order to pass through this barrier, it has to be small enough, and it has to be on a specific sort of transporter in this case, right? So your body, what it does is it breaks down whatever, I don't know, it breaks down the fructose, let's say, into something else that it actually can bring through that wall and through that channel. But it can't actually bring fructose straight through that channel. That's why fructose is considered toxic, because it's processed straight by the liver, and then your body has to do like all this roundabout stuff just in order to bring it across that barrier. That's sort of that would hopefully make trying to like explain this in a somewhat reasonable manner. That's basically why all of this gets converted to adipose, because it's like, I think the conversion ratio is 90% if I remember correctly. It's absurdly high. Man, I don't know if I have that source in my Real Nutrition Science playlist, but basically the conversion ratio is obscenely high. It's like 90% of the fructose that you eat ends up getting converted into adipose tissue or visceral fat in this case, right? So this is why, obviously, honey would clearly give you less visceral fat, right? But that doesn't mean honey is healthy. If you really want less visceral fat, I think we all know what you do. You feed whatever it is just pure fat, and that thing's gonna lose weight pretty quickly because you're putting it in a catabolic state. So
Visceral fat, that's the belly fat that's underneath the unsightly belly fat that actually has metabolic effects negatively. Okay, so 20.
yeah. So by the way, the negative effects for anybody who doesn't know, it will, for instance, they can excrete certain hormones, visceral fat in this case. I don't know if I'm explaining too much. I don't know if I explained this in the Real Nutrition Science playlist. Anyways, besides the point. So the reason why it has negative effects is because this visceral fat will actually increase a certain hormone production, and I'm pretty sure in this case it was cortisol. So it will actually stimulate cortisol, and this basically stimulates your anxiety. So if you're fat, you actually feel more anxiety than you should, right? Also, you probably don't feel good because when you walk into public, I think anybody out there who has experience with that, they would know quite clearly. You get a completely different reaction if you're skinny versus if you're fat.
0.1% less development of that. Then it gets even better. There was a 29.6% reduction or less advancement of triglycerides. So 29.
Okay, if you really want to reduce triglycerides, not that hard. First, I'm gonna say right now, use the Randall cycle to your advantage. There we go. That's the best way to put it. So you either go full carnivore or you go full vegetarian if you really want to make that triglycerides number really nice. But you mix them together and then you got problems with that triglycerides number. Or you can be like me actually and you have leaky gut. Yeah, maybe you have a parasite or you had gut dysbiosis which caused this damage to the gut lining, and that ends up leading to tight junctions being damaged, and then this free flowing of triglycerides through, which is not good, by the way.
9.6% lower triglycerides in the honey group than the sucrose group, and they ate the exact same proportions of food. Now, what they did find is later on into the study, when they allowed them to eat a little bit more at leisure, or ad libitum in this case, the honey group ended up consuming about 13% less. Interestingly enough, one could say, okay, well, they started eating less, so they lost.
I think the reason actually why, I don't think it's actually because they ate less. I think the reason why is because honey literally is just more nutritionally dense than table sugar, right? So if I go get some table sugar, well, I don't actually have table sugar, but if I were to go get some table sugar from a restaurant and I were to like pour it in and then like see the nutritional value, it's like abysmal. I get like nothing out of it. I get adipose, right? I wouldn't really say that's healthy, but I guess you can consider adipose during wintertime. If you're an animal that's going to hibernate, then yeah, that's sort of healthy, like a bear, but you're not a bear, okay? Unless you want to look like a bear and even act like one for that matter sometimes, because you'll definitely you might get some rage sort of stuff. Then don't mess with the honey. Don't mess with the sucrose or the fructose or the glucose. Stick to meat, because you are not a bear, you are a human. If you are watching this, unless your cat or your dog is watching this next to you, then they're also carnivore, by the way. They are also things that are meant to eat meat. They function optimally off of meat. Does that mean that they can't eat kibble? No, they can eat kibble, but kibble is actually very bad for your dogs and cats. I haven't made a video on that. Yeah, I can make that maybe later.
Lost weight, so are the results an effect of losing weight? They definitely could be, but proportionally, the amount of weight they lost to the amount of changes that they saw, or the amount less that they ate to the amount of weight that they lost, was quite a bit different. So they ate 13.3% less, yet ended up having 14.7% less weight gain, right? So that doesn't always add up right there. Point is regardless whether you are talking about the calories in, calories out situation here, there's something very fascinating.
Yeah, because calories in, calories out don't matter. I don't know if he knows that, but...
And with this, we need to progress into a human study, and there is a human study. This study was published in.
I'm going to say right now, this is a very, very sad thing for me to admit, but I don't think you are ever. This is going to be probably the sad part about carnivore, is I don't think people are actually going to be able to find studies on this, because the control conditions that you would need to do are very. You would need to control for so many variables, which people do not control for. Like, you will be able to see a difference in a carnivore versus a non-carnivore. Obviously, you would be able to see clear health differences. But the money one, we already know the money is definitely not on the carnivore side. It is much more so on the vegetarian side. Seventh-day Adventists, if you don't already know that one. 2, when it comes to carnivore, to actually get any of these studies, okay, this is a little controversial, but to actually get any of these studies, you need to break ethics, like big time. I'm gonna say it as it is, because I've heard this a lot. But if you really want good scientific like studies, you need to break ethics. I'm gonna say that, just plain simple. You usually will need to break ethics. If it's biology studies, if it's like chemistry or physics studies, you probably don't have to, unless it's like related to biology. Otherwise, you have to, because there are too many other variables which that biological system is being forced to interact with. So if you're putting this one person through extreme levels of exercise, and then you're putting the other person through like no levels of exercise, but they're eating like a crap diet, let's say like full carbohydrates and only carbohydrates, obviously you're going to see the person who's doing exercise is much healthier. But if you give them a carnivorous diet and then you do the exact same thing, and then you say like, hey, perma exercise this guy and then don't perma exercise that guy, I think you're going to see huge differences. And that's because of adipose and also visceral fat and a couple other things. I'm not going to be explaining that. So this is the problem I have with almost every single human study. When you start to actually like involve humans, I think you have to look at it from a small scale every single time, and then you have to derive it off of that small scale, and then everybody's going to say, well, that's reductionist. You can't do that. Well, yeah, it is reductionist, and that's because that's the best way that we have of knowing. I don't think that this sort of stuff is really that effective usually. Whenever you measure it in humans, it's always... You need to have like extremely statistically significant results in order for that to be relevant, in my opinion, and that's usually very rare, because there's a lot of p-hacking that goes on in science. There's a whole lot of p-hacking.
Science World Journal, and it did a very similar thing. One group of people divided into two, and then they had a honey group and a sucrose group. What they did is for 30 days, one group consumed 70 grams of sucrose in addition to the rest of their diet, 70 grams of sucrose. The other group consumed 70 grams of honey.
Yeah, see, this is what I mean. This is the thing where it's like, of course you're going to see hugely different results. Okay, like you're not controlling 70 grams. It's not considering all of the other food that they're eating, right? Like let's say they're binging on meat, right? And they're adding in carbohydrate, and then now you're just saying, hey, add in more carbohydrate. Like that's not going to help, okay? That really screws with the Randall cycle. They're not gonna feel good. I'd say that much.
So 70 grams of carbohydrates coming from honey. Now, although the results weren't quite as profound as they were in the rodent model group, there was still a... Yeah.
See, this is what I mean. You need extremely statistically significant results in order for this to mean anything. You're not going to get this in a human study unless you really control for variables. Or if it's a huge, like a clearly huge indicator that it does activate or does not activate some certain protein or some certain, I don't know what you want to call it, but I'm not going to be explaining that. I was going to explain the cerule and how it like acts as proteolytic cleaver, or I guess you can call snipping for L-selectin. I'm not going to be explaining that. But if you're interested in cerule, go click my link down below, because that's the only stuff that I use besides iodine.
1.3% weight loss and a 1.1% body fat loss in the honey group compared to the sucrose group. What's going on here? Well, there was also a 3.2% reduction in overall inflammation.
Okay, like the come on. Come on. Like this is not that significant, really.
The reactive protein. There was an 11% reduction in triglycerides. That is nothing to sneeze at. 11% reduction in triglycerides in humans by swapping out sugar for honey. And then lastly, there was a 4.2% reduction in fasting glucose. But we've seen the glucose stuff in other studies. I've talked about that in other videos here on this channel, that yeah, when you have honey versus regular sugar, it does seem to bring fasting glucose down. So what is it that's actually going on here? I mean, could it be the different sugars? Could it be the enzymes?
I'm very curious to hear what he thinks. Enlighten me, buddy.
Could it be the effect on gut hormones itself? Well, with that, we actually look at another study that investigated the whole gut hormone piece. Now, gut hormones or gut incretins have become very famous recently because we've heard of things like Ozempic and Wegovy, where those things are gut incretins, or in this case, they're agonists in those drugs, but they influence appetite and ultimately weight loss, right? So gut hormones are now top of mind. We think about.
And the reason they do that is not ideal in terms of Ozempic, because it basically screws with leptin. And it's like, hey, you are now satiated, even though when you're not actually satiated and your body isn't getting the correct nutritional things that it needs. Let's say you're not getting enough vitamins or minerals of something or another, right? Yeah, it's going to show.
These things. And PYY is another gut hormone that is very similar to GLP-1 in many ways. So there was a study that was published in the American Journal of Clinical Nutrition, and it looked at eating a breakfast that was 450 calories, like a croissant type thing, that was sweetened with sugar, or equal amount calories sweetened with honey. So 450 calories sweetened with sugar, or 450 calories sweetened with honey. And the results after the fact, not just at baseline, but 30 minutes after, and every 30 minutes for 240 minutes afterwards, were pretty wild. They found that there was a significant delay in the ghrelin response. Now, ghrelin is the hunger hormone, right? So what they found is that people got hungry a little bit later, and it was delayed. So basically, the entire ghrelin response was delayed, and ultimately led them to having more satiety throughout the rest of the day.
Okay. I'm going to say right now, there's a reason why ghrelin might exist, as you can guess. Ghrelin exists to tell you, hey, I got enough today. Now, in my experience, just eating only meat, I don't need to eat multiple meals throughout the day. In fact, I never do. I eat once. That's it. I eat one meal and one meal only. I don't need to eat anymore. In fact, I could probably fast multiple days on end after that meal because it is quite filling. But regardless, I eat anyways because I eat anyways. I mean, you don't really need to fast, in my opinion. It's I like the taste. Simple as that. But you don't really have this problem if you're eating just meat, because you are really making sure that leptin is satiated, like big time. The more meat that you eat, basically in this case, the more you are making that leptin not be a problem. Now, when you're adding like carbohydrates in, then you're making leptin a problem because you add in ghrelin, and then ghrelin messes with leptin, and then you get this whole problem. But this does not happen when you eat meat. You get really satiated pretty quickly. Now, does this also apply if you're adding dairy? I'm not entirely sure on that one. I don't think it does. I think that you would probably eat or feel possibly a little hungry throughout the day if you add in dairy, because there is a little bit of carbohydrate in it. So I would assume that would stimulate ghrelin, which would then inhibit leptin. And then leptin would come. Yeah, I think so. So I don't think that this would apply if you're adding in dairy often. I think it'd be difficult unless you're not adding in that much. I don't know. Maybe if if it's nutrient dense enough. Maybe if you're having like organs with it, maybe. But I once again, I would be careful with the organs. I would not recommend overdosing on organs.
which is wild because you're still talking some carbohydrates in the mix. You're just talking a whole delay in the wave there. Of course, they also saw that it blunted the glucose response, which is a huge piece that we know to exist when it comes down to honey. We know that honey seems to lower glucose or keep glucose modulated much more than regular sugar does, which definitely could have influenced the ghrelin, could have influenced the appetite. But they also found that there was a big increase in PYY. PYY is a specific hunger hormone that communicates with the hypothalamus. So it almost tells the headquarters to not be hungry. Whereas, for example, GLP-1 binds to a receptor that is going to almost tell you from neck down or from the gut to say, hey, I'm not really hungry, I don't need to eat anymore. PYY is more of a communicator to the brain. So in a way, it made it so that the brain wasn't hungry afterwards. So even though we're equal calories and macronutrients, if you're trying to lose fat, honey might be a better solution there. But let's...
No, okay. If you want to lose fat, you are not going to add in honey and get really successful results. If you actually want to lose fat and do nothing, for that matter, like me, for instance, I don't really do much. Well, I do a little bit. I do quite a bit of learning. I do a lot of work. I do a lot of work. But okay, besides all of that, if you really want to lose fat, you don't want to be adding in any glucose. I'm going to keep it that simple. Any form of glucose, you want to be tossing that aside, and you want to be sticking to meat. Now, there will be a little bit of muscle glycogen if you're eating skeletal muscle, which is what you usually do if you eat meat. But as a general rule, that's not going to play that big of a deal, as well as the slight amount of amino acids that ended up getting converted into glucose. Not necessarily going to be that big of a deal. But if you stick with meat and only meat, I can guarantee you that you will lose weight. In fact, if you don't lose weight, then let me know. I'm dead serious on that one. Just message me on Discord, get on my Discord channel, and message me there. Because I would be very... I have yet to see one person who has not lost weight doing just that.
Let's investigate more as to why. I want to know why. Well, there was a study that was published in Evidence-Based Integrative Medicine that was a review.
Okay, I will say, the only case that this could be is if your gut is already screwed up, which if it is, go get a GI map test done. I'm going to say that right now for anybody out there who's watching. And if they're not losing weight, eating only meat, go get a GI map test done, because I think there would be some pretty big results. And also go get a regular chem panel done. That's a blood test. That's a certain kind of blood test. Go get a chem panel done, and then you'll see. You mostly want to pay attention to the triglycerides number, and for the gut GI map, that one's sort of easy to read. It's easier to read than the chem panel.
That looked at a lot of different things. So some of the things I'm going to talk about are all encompassed in that review in different journals within that review. We have to look at other sugars that are in honey. For example, there is a sugar called turnose. Now, turnose turns down adipogenesis. It turns down lipid accumulation in the cells compared to glucose. And we've seen this in vitro, where you compare turlose to, say, glucose or even sucrose. And turlose is going to actually downregulate the amount of lipid accumulation and adipogenesis, so fat accumulation, potential hypertrophy of fat cells, compared to glucose. Now, there's not a ton of turlose in honey, but it does make up part of it. Then there's one that's called lucrose. Now, we've seen in rodent models that lucrose is a sugar that seems to, again, downregulate lipid accumulation, especially when giving rats a high-fat diet to try to induce weight gain. So
if you give them a high-fat diet, what? Well, maybe if their metabolism's a little different. But if you give them high-fat, you're going to stimulate... Well, okay, high-fat may also be assuming that you're adding carbohydrates still. Anyways, if you do high-fat, you'll lose weight if you don't add in carbohydrates.
You take rodents in a rodent model study and...
All right, so technical difficulties. Sorry there for some reason. Camera just turned off even though it's like 50% battery. Hopefully it doesn't do that again. Don't do that again, camera, please.
Rodent model study, and you give them high-fat diets to basically induce weight gain. Well, they found that lucrose, this sugar, seemed to prevent some of the lipid accumulation, some of the fat buildup. It did this because it downregulated some of the genes that were associated with lipid accumulation, and it increased some of the genes associated with beta oxidation, or fat burning. And finally, there's a sugar called trehalose. Now, trehalose is interesting because it has been demonstrated to brown white fat. So turn white fat to be more metabolically active. So basically turns it into brown fat, which has uncoupling abilities to basically dissipate calories as heat rather than just store it. And it also seems to have the ability to reduce white adipose tissue hypertrophy, the swelling or growing of white fat, the nasty, unsightly, jiggly fat that we don't really want.
And you won't have if you eat only meat.
But there's one other piece of the equation we need to look at, and that's the enzymatic value of honey. So sure, the sugars are different. And yeah, there's some minerals and nutrients in there that are important. And there's some amino acids for sure. There's like arginine and whatnot. But there's also enzymes. And the first enzyme we have to look at that's in honey is one that's called invertase. And invertase helps take sucrose and break apart the glucose and the fructose from the sucrose. So sucrose is glucose and fructose together. Invertase helps break that apart so that the body can deal with it better. It may seem like, why do we want more efficiency? Don't we want to disrupt the breakdown of this? To a certain degree, but we also want efficiency and utilization of these. So invertase is an important one, but the enzyme that's probably even more important is diet.
I don't know why you would want them. I don't think you would want. You wouldn't want the fructose to be broken down, right? Isn't that what he's saying? I'm a little sus on that one, buddy.
Diastase, because it sort of helps amylase form, and that helps break down starches. So when you have honey along with starches, honey can help the proper utilization of those starches better. So in essence, it helps hydrolyze the starches so that you can form beta amylase, in which you can actually use the carbs better, right? So instead of having glucose elevated for a long period of time, it's helping the cell potentially uptake the glucose and therefore use it and not have it sit in your bloodstream for a long time, which is going to help your area under the curve, which if you are someone that is metabolically unhealthy or dealing with insulin resistance, that's going to make it so you have less potential for weight gain or fat gain.
No, you're still gonna get... Bro, if you're eating honey and if you're not, and you're still adding in carbs and not moving around much, obviously you're going to gain weight. But the thing is, even moving around isn't the thing that's actually contributing. Like, you can lose weight and do nothing. Like me, for instance, if you really want to, or just, there's plenty of other people. But if you really want to lose weight and do nothing, it is possible, because weight and fat, specifically fat, has nothing to do, or almost nothing to do with how much you're moving around, and muscle has almost nothing to do with what you're eating as much. So muscle is more related to whether or not you are or are not stimulating that tissue and forcing tissue remodeling to occur. And adipose, in this case, or fat, is not related to whether or not you are or aren't moving around. It's whether or not you are or aren't stimulating it. Once again, are you putting yourself in a catabolic or an anabolic state? Are you putting yourself in that lipolysis or lipogenesis state? Are you eating glucose, lipogenesis, or are you burning fat rather, and you're actually able to use fat instead of going through glycolysis, and you're going through gluconeogenesis, more catabolic? Yeah. So
because when insulin is chronically elevated, yes, you do put yourself at a potential risk to gain more fat, because insulin impedes lipolysis. Insulin impedes the action of hormone-sensitive lipase, which is what starts the fat-burning process in the first place. So yes, they are the same. And if you're looking purely at calories in, calories out, yeah, you could put yourself in a very similar situation as if you had sugar. But if you're looking down the line and looking at fat accumulation, and particularly visceral fat accumulation, it seems like honey's a win.
Alrighty, so I hope you guys learned a little something in that video. I don't know if I went too long on this one. But as a general rule, man, that's spider bite. Oh, you can really see it. Anyways, as a general rule, I'm going to say if you really want to lose weight, once again, you do not want to be eating carbohydrates. I don't care what other people say. If they are saying I can lose weight and eat carbs, they are completely full of it. Unless they're completely cutting out fat, which I wouldn't recommend, because you're going to be nutritionally deficient, because carbohydrates are all nutritionally deficient. So, yeah, anyways, that's beside the point. If you're interested in all of the details behind everything I said in this video, and related to the science and all of the sources and all of that stuff, go check out the Real Nutrition Science playlist and go watch the entire thing. And if you watch the entire thing, maybe about 7 times, if you're new to the subject of biology and chemistry, maybe even 10 times, and then you come back here, if you watch each of those videos 7 times or 10 times, and then come back here, then you will understand everything I say off the top of my head and why I'm saying all this stuff off the top of my head. Because it would make a lot of sense, and you go, oh, that's why he's saying this. Oh, that's why he's saying that. So it would, yeah. It's I don't recommend, by the way, I don't recommend trying to learn that stuff in detail. Just like watch it once and then go like, oh, okay. But if you really, really want to know things, like if you really want to know how this stuff works, you are actually going to have to watch that multiple times. You won't be able to watch it once and learn everything. That's not how I learned it anyways. When I was watching all this stuff originally and like trying to figure this stuff out, I had to rewatch videos sometimes like 4 or 5 times just before I actually finally understood like, oh, that's what he's talking about. Oh, that's what they mean. And by the way, you can't just watch it in one sitting 4 or 5 times. You have to like sleep, let your brain form the neural connections, and then you have to like repeat that process. Well, I guess the camera wants to keep turning off, so this is what it is. Thanks for watching. If you found the video helpful or informative, please like, share, subscribe, comment down below because it really does help the channel grow. And if you're interested in seeing all of my videos ahead of time, go click the join button down below where you can go see all my videos ahead of time, as well as support me personally. I will be pumping out videos because I am running out of videos. Well, I'm not actually running out of videos, but I'm reaching my deadline, and I really got to start pumping out videos a lot. So I'm gonna be doing a lot of that, and I also want to be prepping for League next season because I want Challenger next season because next season actually looks like it's going to be Assassin meta or more so fighting meta, hopefully. So I'm gonna be playing that. If you're interested in joining my Discord, go join my Discord. Link in the description. If you're interested in Cerule, go click my link down below. Get Cerule from me. The stuff works absolutely amazing, and I also have an iodine in the description as well. So if you're interested in that, go check that out. Once again, thanks for watching. I'll see you guys in the next one. Peace.